Hi guys, I'm going to split this section, this file of notes, into two separate videos. So I'll probably do the first couple slides, give you a little bit of practice to try, and then I'll pick back up once we start actually solving some of the calculator stuff. So if you have a calculator, I would get that out because you're going to need that to try some of these things, or pull up that TI Smart View that I had talked about the other day in the Zoom. All right, so this first slide, I just really want us to think about the ranges. So when I say the ranges, I mean the y values or the outputs of some of these functions. Okay, so let's think about this. Hold on. So let's think about this. We know SOHCAHTOA. And we know, hopefully we know in a right triangle that which side is going to be the longest? The hypotenuse. The hypotenuse is always the longest side. Okay. So if we think about sine, it's opposite over hypotenuse. Okay, so if we think of some just random examples of opposite over hypotenuse, where your hypotenuse has to be bigger than the opposite side. So let's say 1/2, 5/6, 8/10, I don't know, 5/12, 3/4. Okay, anything where basically your hypotenuse is larger. What do you see coming out of these values? What types of outputs are you going to be getting? Okay, since the hypotenuse is always bigger, this value has to be less than 1. Now, we will get out 1 from the unit circle for sine. Okay. Now, we can also get all of the negatives of all of these depending what quadrant we're located in, because we know that sine is negative in quadrants 3 and 4. So the outputs or the range for sine are going to be between -1 and 1. The 1 and the -1 come from the special angles on the unit circle. Not special angles, the quadrantals on the unit circle. Okay, now if we think about cosine, that's adjacent over hypotenuse. So it's the exact same idea except with the adjacent side. So its range or its outputs are always going to be between -1 and 1. Okay, once again, the -1 and the 1 come from the values on the unit circle with the quadrantals. And then all of the in-between values, okay, whether these are the opposite or adjacent, the hypotenuse is always the largest, so they're always going to be less than 1. The negative values, the part from 0 down to the -1, come from if they're in the quadrants where that specific trig function is negative. Okay, now let's think about, these are a little bit trickier. Let's think about cosecant. So we know that that's 1 over sine x. Okay, so if you think about this, if you take, for cosecant, that would be hypotenuse over opposite. For secant, okay, that would be, let me write this a little differently. Sorry. For secant, it would be 1 over cosine, which would be hypotenuse over adjacent. These are going to work similarly like these did. So these are going to have the same ranges, just like these have the same ranges. So think about this. If your hypotenuse is always bigger, and now it's on top. So if I take all these examples from above and I now flip them, these are just random examples. And once again, they could have the negative side of all of these as well, depending on the quadrant. All of these values are now what? Hopefully you're thinking they're bigger than 1. Now, once again, they can include 1 because we know that cosecant is going to be 1 whenever sine is 1 because they're reciprocals. If you flip 1 over 1, it's still 1 over 1. But hopefully you're recognizing now they're all bigger than 1. And technically, they could go as big as they wanted. Since your hypotenuse is always bigger, I could put 1,000,000 over 1. Well, technically that wouldn't work, but that's for another day. And remember, you could have the negative of these as well. So it's going to go from -infinity to -1. And then it can't be between, okay, the -1 and 1. So we're going to pick back up with 1 to infinity. And that's the same for both of these. So if you think about the values that are and aren't going to work, these are now, since the hypotenuse, the bigger values on top, they're always going to be greater than 1. Like I said, the negative part comes in based off if they were in quadrants where that trig function is negative. So if I had this for secant placed in quadrant 2, it'd be -2. Okay? Now, I wouldn't get super alarmed if you're not like super clear on these ideas. Okay? If you're like, I have some questions, jot them down, save them for office hours, but don't be like, I can't do any of this. You totally can. Okay? Let's talk about the last two. Now, tan is opposite over adjacent, and cotan is just adjacent over opposite. Now, think about this. The opposite and adjacent side can be anything they want. Okay? It's not like one has to be bigger, one has to be smaller. They could be any ratio that you could think of. Okay? It's the hypotenuse that always has to be the bigger, and they're not in those ratios. So if you think about it, they can be anything. So these are going to be all reals for both. Okay? Now, like I said, you'll still be able to do what's coming. Okay? So here's where you're going to start to need the calculator. So, shoot. Smart View. Now, you really need to pay attention to whether the angle that is given is in degrees or radians. So clearly for degrees, you're going to see the degree symbol. Now, I'm going to do all the ones in degrees first, and then all the ones in radians second. I would do the same thing when you're doing practice. I would do all the ones that are degrees first, or all the radians first. It doesn't matter which one you do first, but I wouldn't do a degrees, then a radians, then a degrees, then a radians, because you're going to have to switch modes in the calculator. Okay. So I'm going to do all of the degrees first. So to check your mode, shoot.